Hello everyone, this is the ME Tutor. We're going to do a little DiffyQ today and solve the Brachistonechrone problem. You can read the problem here, you can pause the video and kind of stop it. I'm not going to read it all because it's really complicated or really long. But basically there's a lot of different great scientists that kind of went over and solved this problem. But basically it's what it is. It's a particle. The closest path between a particle without it being straight under it with the force of gravity upon it. There's part A, B, and C, so I'm going to get right into it. So part A is pretty simple. All you're going to do is basically use algebra to try to solve for y prime. So 1 plus y prime squared times y equals k squared. And that's going to simplify down to 1 plus y prime squared equals k squared over y. And then that's going to simplify down to y prime squared equals k squared over y minus 1 square root both sides, and then we're just left with y prime is equal to plus or minus square root of k over y minus 1. So, and we're going to deal with the positive term. We're going to ignore the negative one because dy dx is a increasing function. We're not going to deal with the negative axis for this problem. I'm just going to scroll down a little bit, get room for part B. Okay, before we do part B, we're going to manipulate this one more time. Since we can multiply, since everything's inside, sorry, I forgot that k squared. So since everything's inside here, we can kind of multiply everything by y over y, which is basically just multiplying by 1, which we're allowed to do. So we go k over y over y. And see, and that will help us later on for part B. So I'm going to write part B right here. And now we're going to introduce a new variable, kind of like what it says here, introduce a new variable by the t relation. Y equals k squared plus sine squared t. So that's how you kind of get the t variable in this time variation. Y equals k squared sine squared of t. And what we're going to do is we're going to take the derivative of this function. And the derivative is kind of do u sub, but I'm going to skip that since kind of maybe it's focusing on differential equations. 2k squared sine of t cosine of t. And what we're going to do now is we're going to prove that it equals this function here. In order to do that, we're going to need both to use this equation and this equation. What we're going to do is we plug this in for y prime, and, or sorry, I got ahead of myself. We're going to split this up now to dy dt is equal to 2k squared sine of t cosine of t, and then we can multiply dt over both sides, and that gets rid of this one, and then you just have dy is equal to 2k k squared sine of t cosine of t, and on this side this is actually dy dx is equal to square root of k squared minus y for y. And what we're going to do is the same thing, get dy by itself, and now we're okay, that's that. So now inside the square root, we're going to plug in this y here. So plugging that y, this y here into this spot, because we're going to prove that they're equal. So you're left with k squared minus k squared sine squared of t over k squared sine of t. And what we can do Now, we have to use some trigonometric functions that we have to remember. And one of the more important ones is this one, sine squared of t plus cosine squared of t equals 1. So we have to solve for cosine. And this is going to fit in here. I'll show you how. Let me scroll down real quick. And we're left with the square root of k, 1 minus sine squared of t over k squared sine squared of t. Alright, so now what we're going to do is we're going to plug this into here, because this looks a lot like this. And that gives us, I'm not going to forget the dx. Alright, so since it's under the square root, what we can do is, first off, this equals 1. And since these are square, we're just going to pull them out. So that equals cosine of t over sine of t dx. And now, since this is this equation right over here is equal to dy, we're just going to pull that down, and we're going to go, okay, this dy and this dy are the same dy, we're going to prove it. When we pull that equation down, we're just left with 2k squared sine of t cosine of t. And since the cosines are on the same, they kind of cancel out. And then we multiply sine of t to both sides. That cancels out, and that's left with us dx is equal to 2k squared sine squared of t. And that's part B. Alright. Oh man, that was a mouthful. We're not done yet. We're kind of close. So I'm just going to scroll down one more time and get a new page real quick. Alright, now we're left with C. And this part is kind of, it's not too difficult. Just bear with me. So they say that theta is equal to 2t. And then we're kind of do the algebra real quick. We're still dealing with this equation. I'm going to put this over here, 2k squared sine squared of t equal to dx. Okay, so we do that. I'm sorry, there's a dt here I left out. Sorry, my bad. Anyway, so we have theta equal to 2t, and then if we take the derivative of this function, we're going to get d theta is equal to 2 dt, and then d theta over 2 is equal to dt. And also if we solve for this, this is also equal to theta over 2 is equal to t. Alright, so what we're going to do is we're going to do what they say and plug it in. This for this, and then theta for and this for t. So that gives us 2k squared sine squared theta over 2. And then we multiply in theta over 2 dt. And that 2 and this 2 is going to cancel, so then we're just left with k squared sine squared theta over 2 dt is equal to dx. And the reason why they did that, this theta over 2 will help us in the next part, because we have to do double angle formula, or not double angle, sorry. I forget which formula it's called, but basically this sine squared will convert into there's an identity, which it goes 1 minus cosine of theta d theta k squared 1/2. This is what it'll turn into. The trigonometric identity, though, I'm going to write it over here in the corner, is going to be 1 minus cosine of 2 theta over 2. So this 2 and the 2 that we have in theta cancel out. So then we're just left with this function here. And that is equal to dx. And then what we do is we just integrate in terms of theta, and this side in terms of x. And then we're just left with k squared 1/2 theta minus sine of theta equals x of theta. Yep, pretty simple. And it's not too bad. Thanks for staying with me the whole time, and let me know in the comments down below what I can do better, and even what kind of problems to work on. I'm always looking for good feedback. This is my second video, so thanks everyone for watching.